Well, hello there! I hear you're not a fan of math. Well, maybe it's not that you're not a fan. It's just that you would literally rather be doing anything else. Okay, so it was fun once, right? A little ways back. Well, a little more. A little more. Yep, nope, yeah, okay. So it was fun once, maybe. But then there were all these X's, Y's, triangles, P's, F's with random X's caged inside their brackets. And whatever this weird thing is. And it all just looked like someone was there to mess with you. And I think they were. Alright, I'll let you know a secret though. It's really no scarier than this cute little kitten. Even though it really feels like you're coming face to face with a slightly bigger cat. Roar. You see, variables are just placeholders. They can be whatever you want them to be. Just represent something. So imagine you have a cute kitty, and you want another. How many cute kitties do you have? You have 2. And what is it that you have? Cute kitties. So you have 2 cute kittens, right? But if you have a kitten and a dog, you don't have 2 dog kittens or kitten dogs. You just have a dog and a kitten. X's and Y's, they're the same thing. If I have 1x plus 2 x's, I have 3 x's. But if I have 1x plus 2 y's, I have 1x and 2 y's, or 1x plus 2y. Same thing as the kittens. You see, these are what we call, in mathy terms, like terms. So they're like because, well, they're the same, and they're terms because, well, I guess we should probably take a step back. A term is simply a grouping of letters and numbers and all these just mushed together into something separated from a plus and a minus sign. So if you have 2xy, that's one term. We call that a monomial. If we have 2xy plus y, we would have 2 terms. We would call that a binomial. And if we had 2x squared plus x plus 3, well, that would be a trinomial, like a tricycle. 3 terms. Alright, so every time the term is like, we can add it. If it's not like, don't add it whatsoever. Okay, so what are some examples of like terms? We've already seen a few of them, because we had x plus x, or puppies plus puppies, or kittens plus kittens. Those are like terms, because x plus x is the same, y plus y is the same. You would get x plus x equals 2x. But x plus y, you can't do that because puppy kittens. Alright, so where it gets a little bit more complicated is when we start to have multiple variables. Let's look, for example, at 2xy and xy. These are like terms since the variables are the same. So each term, its grouping of variables, is the same. And you might be saying, but you said you can't combine x and y because puppy kittens. But actually we aren't. And the reason why is because 2 times x times y is very different than x plus y. X plus y is trying to combine those 2 different terms. Whereas 2 times x times y, that's the actual object. That's the term that we want to be adding together. This may take a little bit of a look at what multiplication actually means. Multiplication is simply adding the number to itself a specified number of times. So if I had 2 times 4, I could either go 2 plus 2 plus 2 plus 2, or 2 plus itself 4 times, or I could go 4 plus 4. Both ways I get 8. 4 times 2, or 2 times 4, is 8. If we wanted to have 2 puppy kittens, so 2 groups of puppies and kittens, that's the object. That's the term that we want. What that's telling us is that we want a group of puppies, the group of puppies and kittens that we have together, all together in a nice little clump, and we want to make 2 of those. So we want to double it, essentially. So 2xy plus xy, they actually are like terms. It would be 3xy. But what about 2xy and yx? It looks a little bit different, but it's kind of the same thing. Because if I told you that you had 2 groups of puppies or kittens, or I told you that you had 2 groups of kittens or puppies, would you really think it was anything different? Unless you're one of those people that's like, really loves one of those animals over the others, you say, well, no, they're the same thing. You still have all of that in that group. You still have puppies, kittens, and the number 2 in that group, no matter which way you do it. So those are actually like terms. 2xy plus yx is 3xy. It could also be 3yx. In fact, I could actually go y3x. It's just, that would be kind of confusing. So what we do to try and simplify it is we usually write the number, or the coefficient, first, and then we write our variables in alphabetical order. Just makes things look a little bit nicer. What about cubes, squares, those powers of 4, and radicals, all those things? How do we add those? When are those like? Well, if you've learned about exponents, you know that x squared is just x times x, or 2 squared is 2 times 2. The exponent just tells you how many times you multiply it together. 2 to the power of 3 would be 2 times 2 times 2. Or x to the power of 3 would be x times x times x. So is x squared the same thing as x? Well, if we have a puppy, or we have a puppy added to itself puppy times, okay, that example doesn't really work very well, but you can tell already that they're very different. And if not, what about this? If we have 2 and 2 squared, are those the same things? Is 2 the same as 4? No, they're different. They're not like terms. Alright, well, so there you go. Now, I could add 2 plus 4 because I know that that's 6. But if it's a variable, I don't know that I'm going to use 2. I could be using any number. And since 2 and 4 are different, and I don't know if it's 2, 3, 4, 5, 6, I can't actually add x and x squared. They're 2 different things. One is x times x. So x squared and x squared, are those like terms? Yeah, those are like terms because one is x times x. The other is x times x. So we get 2, and what do we have? X squared. So 2x squared. Now, what about something like this? What if I had x squared y and xy squared? The first thing we're going to want to do is break it apart. The first thing is x times y, whereas the other one is x times y times y. So it's not the same, because one has an x and 2 y's, and one has 2 x's and a y. Different. Not like terms. Can't add them. Don't try it. Now that we finally have the like terms out of the way, there's nothing that we can't add. So let's try a few examples. I'm going to come back and see how you did. How'd it go? Rocked it? Excellent. If not, you know, there's always that rewind button. Anyway, kitties. All positive about your math, but then you sit down for the test and what happens? Boss level. So that gets thrown at you. You see a question like this. 2x plus 3y plus 3xy minus 2x plus 3xy plus x squared minus 8x squared. And you're like, what? That's not kittens and puppies. That's big. But the secret is, that's all it is. It's just a little bit bigger. So the first thing you want to do is breathe. And then remind yourself, just kitties. What did we do before? We added any terms that were like. So what we got to do first is find out which terms are like terms. You can do this however you want. I like to highlight them, but you can underline them, you can put pictures of puppies, kittens over top of it, whatever you want to do, as long as you know which ones are your like terms. First terms that are like terms, we got 2x and we have negative 2x. So that's a group of like terms. We can add those two together. And what do we get if we add those together? Well, if I have $2 and I spend $2, how much you got left? Nothing. So 0. It's gone. Poof. Vanished. Money. Anyways, 3y is the next thing we have. Now, we can look along. We cannot find another 3y. There's other things similar, but no other 3y's. So what do we have? Well, we have 3y. Perfect. We're just going to write that down. We're going to keep it there. Next thing we got 3xy's and we got 3yx's. All right, so this is back to the, is xy different than yx? No, these are like terms. And if we have 3 of them and another 3, we now have 6 xy's. X squared minus 8x squared. Well, let's look at this. If I have x squared and I take away 8x squared, what do I have left? Well, if I have $1 and I spend $8, I now owe $7. So I have minus 7. And minus 7 what? Well, minus 7 x squared. So when we combine all that together, we get our final answer of, well, 0 x's, so we won't even worry about that, 3y plus 6xy minus 7x squared. Now, typically we like to write this in a nice form where we have our highest exponent first, or our highest degree first. So the x squared, that's our biggest degree. That's the number with the highest exponent, so we write that first. So we'd say negative 7x squared plus 6xy plus 3y. And there you have it. That's it. That's all. We've done it. We know how to add, subtract polynomials. We know what a polynomial is. So I hope that this really helped you. I really enjoyed this. If you want to learn about some other things or you still have questions, make sure to comment it down in the comments below. I love reading your comments. I want to see what you have to say. I want to see what questions you got, what questions we can answer in future videos. But remember, beyond anything else, everybody can do math. And I really, really mean that. Doesn't matter how many times it's beat you down before, you can do it. And also, don't forget, kitties. Alright, so thank you for hanging out with me. Thank you for checking this out. My Twitter link will also be in the description, so you can go and hit me up there if you got any other questions or things you want answered. But it has been awesome hanging out with you. Until next time, keep memeing and mathin'.